So how many of the functional groups have you found? Well, first, there's a nitrogen here, and that is an amine. There's a nitrogen also over here, but if we notice, it's got this double bonded oxygen nearby. That makes it an amide. There's a hydroxy here. That's an alcohol. And this oxygen that's kind of trapped in here, that's an ether. This conjugated ring is aromatic. It's also called an arene. So let's look at this one. Here we have carbon. It's double bonded to an oxygen and to a hydroxy group. That's a carboxylic acid. So this whole thing here we have a nitrogen, and it's next to a carbon that's double bonded to an oxygen. So that makes that an amide. This ring doesn't have any double bonds in it, so it's not aromatic. Here's a nitrogen, but it doesn't have, the carbons next to it are plain vanilla carbons, no double bonded oxygens, so this is an amine. Here we have a trapped oxygen, which you might think was an ether, but if we look next door, there's this double bonded oxygen. So that's not an ether, it's an ester. And here we've got an aromatic ring, because it's got these double bonds that you have a double bond and then a non-double bond, a double bond, and a non-double bond. There. That makes it aromatic. In your problem set, they're going to call these arenes. Okay? So you need to memorize these functional groups because we'll be using them and talking about them a lot. You need to be able to pick them out of these molecules. So let's look at carbon being a special case. The carbon can never have more than 4 bonds, but sometimes it only has 3. When we get carbon with a positive charge, a formal positive charge, it's a carbocation. And it only has 3 bonds. We can also get a carbanion, and it also just has 3 bonds. The difference is it's got a lone pair, and it'll be negatively charged. And this becomes important when we're counting hydrogens on our line figures. The carbocation here has no hydrogens. On the carbon with the plus charge. Okay? This one has one hydrogen. That's because this is a carbocation. It makes 3 bonds, and so it's got a hydrogen that's not drawn, so that it has its 3 bonds that it's supposed to have. This carbocation will have 2 hydrogens. So it'll have 3 bonds. It'll have a hydrogen here and a hydrogen there, and still have a positive charge.